Welcome back, everybody. Today we're going to be talking about multiple datum features at RMB as well as hole patterns as datum features at RMB. So why is this coming up? Well, I saw a Reddit post a few months ago asking a question about a part similar to this with a feature control frame that had A-B and then C-D as a secondary. And they were asking kind of, what does this actually mean? And they didn't explicitly say it, but presumably this feature control frame was attached to like a hole or a notch or some sort of feature that was being clocked relative to the C-D. So in this video, I'm going to go over sort of what this actually would mean. So in the 2009 standard, a pattern of features at RMB basically says that a datum feature simulator is created for each feature in the pattern, and these simulators are located at fixed locations relative to one another. And then the simulators are simultaneously either contracted or expanded, depending on whether or not it's an internal or external feature, from their MMB, or maximum material boundary, towards their LMB until they make maximum contact. So there's a couple of examples in the standard that are quite similar to this part, but we'll go over it. So the datum feature simulators would start out at the same size, at their MMB size, and simultaneously they would contract towards the feature until maximum contact is made with the features. And then for the secondary datum, similarly, you'd get the two pins that would start at their MMB size that would slowly expand until they make maximum contact with the holes. So that's basically what the gauging of that feature or of that feature control frame or that datum reference frame would look like. However, there's a couple problems with multiple datums at RMB that I'd like to sort of just point out and talk about a little bit. So the first one, if you think about it long enough, there's a lot of situations where there might be multiple solutions. There might not be one unique solution. So for example, I think you could argue that all three of these, maybe other than this one, would be considered, maximum contact. I guess if there was like a flat face here and a slightly flat face here, you could have a situation where all three of these would be reasonable. I think an easier way to picture it is with this, if you had, two holes and the datum feature simulators expanded, and one of the holes was made slightly undersized or had some sort of irregularity, and the datum feature simulator locks up on that hole before the other holes even made contact with a wall. So what do you do in that case? Well, they sort of solved that in the 2018 version of the standard by adding this last sentence here that says, when irregularities of a feature may allow the part to be unstable, a single solution shall be defined to constrain the part. So they're saying, if you get a situation like this, maybe a push down on the part, or push on the datum A or the datum B or something like that, and that's your datum reference frame. The problem with this, and maybe this is up to you for how you're going to use this, but the problem I see is a lot of the time when you're using datum features at RMB, it means that there's some sort of there's material being deformed in a way, let's say. So if you had like two dowels, you could press fit a dowel into this one, and then you would sort of expect that this one would also get full contact on the dowel. So to me, it doesn't really make sense that you would push it down, because realistically, if this was the function of the part here was two dowels and they just happen to be the perfect distance from each other, but this one was a bit deformed, you would get a centering effect on both of these holes. So maybe that is up to you as the designer to say, when, if you get this unstable situation, the second datum feature simulator continues to expand into that hole until it makes maximum contact. I've talked with someone who has their ear in the standard boards meeting, and that is something that they had talked about, I think specifically with not patterns necessarily, but if you've got two dissimilar features or features that are different sizes, does the datum feature simulator of one continue to contract or expand when its counterpart, or when the other feature has already locked up. And it doesn't sound like that was ever solved. The other problem that I've noticed, and maybe this has been talked about already, this is a little bit easier to imagine happening, is that all of the examples in the standard have features of size that have the same tolerance zone. So these are both 0.1 millimeters. But if you had a feature like this with one feature having a 1 millimeter tolerance zone and the other one having a 0.2 millimeter tolerance zone, how does that work? I would assume that the datum feature simulators, in this case, contract on a percentage basis, so that if once half of the tolerance zone on this 20 millimeter feature has been eaten up, half of the tolerance zone on the 15 millimeter feature has also been used. But I could also see someone arguing, well, that's not simultaneous. It actually means that for every 0.1 that this feature, datum feature simulator contracts, it contracts 0.1 on this datum feature simulator. But I haven't seen that addressed. And I do think that is something that should be sort of explicitly stated. Anyways, if you know the answer to this, or if you have a point you'd like to make about it, definitely leave it in the comments. Have a good one.